So good evening, folks, and thanks for coming into the last session of today. So this is about Java source to byte code transformation. Yeah, the hidden story. So we're going to talk about what's happening, how you transform the source code into the byte code. From the Eclipse perspective, if you look at the Eclipse IDE perspective, you can see that you will have the source code and somehow the disassembler view, you have the byte code. So there is an agent that does this transformation, and that's the compiler. I could have simply said the internals of compiler, but then I'm trying to get into management, so all these new words of transformation, etc. So it's all about internals of compiler, how the compiler does, what it does, and just a peek into what goes on inside. Will you guys use any of them? No, but probably it'll give you an insight of what goes into the compiler, how the code will look when you see the byte code. The compiler can be divided. There are two basic stages when I say word compiler. It's a front end and a back end. So what is the source code? It's after all a text file. There is no structure to it, right? And then you have the byte code, which is essentially bytes. So the first stage of the first job of the compiler is to get a structure out of it. And when I say structure, it's about something like a tree, you can imagine, and then the backend comes, and then we'll transform into the byte code. It's something akin to a coffee machine or a coffee making process where what on the left is the beans, the source code. Then the front end is that grinder which, whether you want espresso, whether you want this filter coffee, or whether you want put it in espresso machine. So tweak that. And then the intermediate structure, I know it doesn't look like a tree at all. It's just coffee powder, but we have the intermediate representation, and the backend is the coffee machine where you put in I'm talking of the old style machine where you put in that intermediate format, and you get the coffee, which is the byte code. It's very similar to that. So I'm going to talk about this front end. So let's get something more technical about it. So what do you see here? It's a picture it's a scenery, right? So let's forget about the code for some time and let's see how we can compile this picture, how we can get a structure to this picture. And what is our task at hand? We have a picture compiler. Sorry for the lack of creativity. It's called PCJ. Our compiler is of course called ECJ, right? Eclipse compiler for Java. So then it does only two things. One, it accepts the picture, and one, it rejects with helpful error messages. So let's write a compiler. Let's have it tomorrow. It's like saying, let's put a rover on the south pole of the moon tomorrow. And I'm saying this on 22nd of August. By 23rd of August, I expect it to be there. But like everything, we start with simple steps dating back to 1964. There is it's a small step where we start with something very small, and we still don't get into this. We get into steps, some baby, some not so baby, some successful, not so successful, and finally, on to 23rd of August, we put something onto the moon, and probably beyond that. Like any project, the compiler also, let's follow some of these factors and let's see. So before we forget, before we are over the moon, this is what our task in hand. Now, let's start with the specification. So let's describe the specification in English. Version 0.1 says, what is a scenery? What is a picture? It has components, it has sky, water, and it has order should be from top to bottom, sky should be top, water should be down, and all components are mandatory. That's our. So with that information, do you think this picture passes? Do we expect our compiler to accept this picture? Yes, it accepts. Because sky is light blue, dark blue, watercolor, etc. All matches. Now, are these pictures accepted? First picture? No. Because sky is missing, because we said all components are mandatory. Second picture, let's look at it. It's not uniform, right? The color should not be uniform. Color should be uniform. Is not uniform because there is some object out there. So do we bail out? We don't bail out an actual compiler. We do something called error recovery. We go through this code and we see that, okay, something is here. Then we try to recover that error by either, can we remove something? Can we remove this element? Or can we add something from the previous element? Does it fit into the rule, etc.? And that's error recovery out there for you. Now, if you look at the small things, it's like you missing a semicolon, which is fine that we are able to fix it. But if you look at the big board, it is more like, one token is additional or one keyword is additional, so we figure out how we do that. We want to enhance our compiler, right? We want to add more objects. So the one thing which I want your attention is, you see that strike over, then green color. So this is how the actual specification will look, language specification will look. And as we progress from one version to another, where we allow more things, say we allow multicolor objects, we allow the water can have objects. So now version 2.0 now allows the boat. Next version, we allowed the land also. You can see that the land can have objects. The type of the objects must be one of the sand, plant, rocks, or a compile time error occurs. Compare that to the actual language specification. It says this is about a switch expression. The switch. Then that expression is there. The specification says prior to 21 says the type of the expression must be char, byte, short, int, or a compile time error occurs. Is the bottom picture accepted? No, because there are objects which are not allowed, right? And so on and so forth. We'll remove things like order can be anything, so that now the sky, there could be land above sky. All components are optional, so then the picture bottom is also accepted, and so on and so forth. And then the 10.0, blah blah blah, right? And then you have that accepted. But do you accept this? We don't. This is like, looks similar sometimes. You have class objects. So the top one is like Java, and you feed that with the other one. The bottom one is probably you have the C++ objects, very similar, builds out. If anyone is interested, if you want to go to the first place, you can travel with me home to India, 20 hours without including flight delays. But if you are interested in the bottom one, just cross over. You can see the pumpkin festival, but this is the next version. This was last year's picture. So that's about it. Now we have come to the, now let's see whether we can put some structure to the English. So what were we talking about in English? We are talking that we have components. The components could be sky, water, land, etc. Now we put a structure to it, a grammar to it. And this is actual grammar that you can see in the code, where we say that the picture can have components, and the components can be one of sky or water or land. And how can it be? Can there be multiple components? Yes. This is the rule which says on the left-hand side says the components, and the components can be component, comma, optionally, one more component getting added. So that's how we are slowly getting into the structure of the grammar. And then we add something more to it. Not only we want the structure, we want to add, we want to create a tree, right? That's a middle intermediate representation. To create a tree, we require functions, we require actions. Those actions are captured in this. So what are we trying to do here? We are trying to create a specification which helps us magically, somehow, if we have a 3D printer, it will give us this coffee middle machine, which I can keep, feed the Java beans, which is the source code, and gives me the abstract syntax tree. So this is what we are trying to do this. So do we actually have that? Let's come to that. Now, to the bigger picture. So we are still looking at the beans, the front end, and the structure immediate. And from the picture's point of view, what will it do? It will take this picture and convert into a syntax tree, which will have sky and I think water. Even I'm not able to read what I've written. Yeah, I think it's water, and it'll have its own properties, and some properties could be derived. Let's say, okay, this is a sun, and why could it be sun? Because it's orange. So it could be sun. So based on situations. It's like based on a particular statement, we derive what could be the type. So something akin to that. When Stefan Hermann was there, he has written most of the type inference stuff. So any further questions you can ask him. So, yeah. And from the source code point of view, this is what we get. Not sure whether it's readable. Yeah. So on the left side is the source code, and you get an abstract syntax tree. So we still haven't figured out how to make this. What does this coffee machine, that intermediate, this phase, the front end, it's actually a scanner followed by a parser. But do we make it? Do we have to write it every time? No, we don't. We do have a 3D printer with us. So what do we have? We have a language specification that changes with every version. We write the grammar. That's our part of it. Then we have something called a parser generator, something like a 3D printer, which would give us the basic backbone of creating the front end, which is the scanner and parser. And then we add our consume functions to create a tree, to write whatever we want there. Then you have addition. So it may not be as simple as it is, but in principle, this is how we create this intermediate machine, and then we have the front end for you. And then we'll create the AST. Then what do? We take this AST. We still haven't figured out what the backend is. We'll take this AST and create the byte code. No, I assure you I'm ending up the slides before you doze off. So the backend is something like, what is the input? We have a tree. Let's assume it's a Christmas tree. And let's say the backend has multiple faces. It's like 4 kids. One kid come, put something onto the Christmas tree, which is the type resolution. Then another kid will come, add stuff, looking at what the other one has added. It'll add type inference, and then they will do flow analysis. We'll come to what this is, and then ultimately the code generation. That's how the logic flows. Okay, now to code. Let's get into some. Can everyone see this? Yeah, sure. Uh, it's about, let's say, what is here. The backend comes here and it says my class. Where is my class? And it tells it is in second dot my class. So this is a phase which will go around, check what is available, and refer the type and figure out what type it is. Not going into too much detail. Let's get into the type inference part. Here, look at this part, the diamond. We don't specify the type, so we have to infer the type. And that inference comes from a lot of rules, but here you look at the target and you see that it has to be an integer type. Now to make it a little more complicated, now what is the type of X? Uh, yeah, string. what what does it? What does the type of RH it? It has to be an integer, right? So how do we do that? We figure out that this is a lambda expression and then look at the lambda, look at the SIM, that is a single abstract method, figure out that it is this and returns the u, and what the u is. We use an integer, and so it's a transformation from from string to, or you can get it from here. So this is again involved, and um, then we have where we don't specify the type. So that's about a peek into the type inference part. Now let's get into the flow analysis part, and before we get into the details of flow analysis, let's see what this um, where is the binary? Yeah. So let's look at the foo. How many foo 0? Now, we have the binary here on the right side, and this is contributed by flow analysis by different phases. Uh, Finally, how many local variables are here on foo 0? 1, 2, and the parameter 3. But we have, it says 4 local variables. Any reason? I know most of you know the answer. Can someone shout? Yeah, right. This compiler internally will insert this because it is not a static function, it is an instance function. So this is again compiler which does under the hood. If you don't believe me, if I put it static, and yeah, this doesn't refresh, so don't ask me why. So okay, thank God, it worked. So locals 0. So these are the small things. And now look at the stack. That is one thing which I wanted to. So these are some things which they calculate. Why is it stack 2? Because at any point of time, maximum it is 2. That's all you require. How do we calculate? We go through all these things and see whether it's a stack machine, right? You put it in the stack, you consume. So you put constant 2, I stood 1, means that has gone away from the stack. And then you load 1 and I add, then 2 things are gone away from the stack. So that's how you calculate. So these are all done by the compiler. But does it do only the correct stuff? No, it doesn't. Let's look at the, let's move it. What do you think the error here is? I'm not going to hover. So, any guesses? Hmm? Yeah, not. Yeah, it is. It may not be assigned. local variable may not have been initialized. So who does this analysis? It's a flow analysis phase of the compiler that does the analysis and give you this error. So that's another. Now you ask Stefan, he will give probably a 3-hour lecture on flow analysis, because with Java 8, he had the entire null analysis package, which primarily was on the flow analysis part, right? Majorly, Stefan? The null analysis part, which is using annotations, which is widely used. So it's an entire, you can build tools around that. And finally, I think that, yeah, flow, I don't want to go into further details of, uh, let me just give you the last thing, which Stefan asked me whether I'm going to show it. Maybe I'll show it. It is not only so we have seen the bytecode, the compiler generates it, but is that the only thing? It generates a lot of other stuff. It generates a local variable table. Now that's also generated from the flow analysis primarily, especially this part, the boundary 0 to 9. Like it says 0 to 9. That means 0 to 8, the variable local is valid. But the variable sum is valid only from 2 to line number 2 to 9, or return is valid only from 7 to 9, 7 to 8, 7 and 8. So these are the information that's added here. Why do you think it is, why is it necessary? Because you don't have to, you can reuse, say, you're loading onto one, but if that variable is not alive at a later point in time, you can still reuse it. You don't have to go into, you can still use iload1, iload2, or iload0, iload1, etc. Typical code generation stuff. There is something else which which is not visible here, but let's see. Again, I think I need to. Something was stack map table, which is about verification. I will not get into the details of it. Not that I know too much about it, but it is about verification of what kind of type is available on the stack, what are the local variables, etc. This is for doing a verification of programs of the bytecode to make sure that we provide only right kind of bytecodes. So with that, let me just briefly get back into the into this code, into the no. Looks like it doesn't want. It is, yeah. Self-explanatory, right? So, okay, so this is, so what I showed earlier, the pipeline was about the compiler. Now, the compiler actually, from an IDE perspective, sits at the bottom of the IDE. And we have different stages of the compiler, like parse, then we have the state types, flow analysis, etc. These provide, probably APIs is not the right word, or maybe it's the right word to some extent, provide classes or APIs which can be consumed by the layers above, that will give you the power to do a lot of stuff. For example, you do Command Shift T for the searching of the type. Where does this come from? It comes from, first it will parse, and in the parsing it will do something, keeps index something, and then, oh, so it's going ahead. So, and then you have Java element view or Java model view. All of these things would take up, would consume some of these things and give you that particular feature. From the last slide point of view, I think I missed one thing before. If you think about the pie, if you think about the image, we talked about generation of the code, which is the bottom part. But we can also do a refactoring. Mm, Most of the UI part, most of the refactoring happens from the AST layer, where you can take this AST and rewrite it. So this picture can be transformed into another source, another picture uh, using the refactoring APIs. If I get into the, sorry for switching and show. I think I have 5 minutes. I'll just close with this. X.Java. Yeah. If you have this is a simple example of intermediate format. Now, this is not exactly the compiler intermediate format. It is about the intermediate format, which you can see the abstract syntax tree, which is like one layer above. But in principle, it's the same. So in fact, you can see that there is a type, and the type is like type declaration. And what does it have? It has parameters, it has body declarations, and it has a method declaration. When you click on that, you can say this is the method declaration. And as we have discussed, different compiler phases will decorate this abstract syntax tree and get you different information like method binding, what is the kind of the method, uh, more details about what are the parameter types of the method, and stuff like that, whether it has an annotation type arguments, and so on and so forth. Like for each and every construct, even if it is new, we do have. And to close, this is something which we repeated yesterday. Is like you look at the record, and for the record we have it is just one line, and the compiler puts a lot of code inside the class file by synthetically manufacturing this code. And so these are some of the things that goes into the compiler. And I think with that, I'll probably give you a few minutes back. We can head down. Thank you very much. Any questions? Thank you. Okay, oh yeah, I was expecting why you didn't ask. In the compiler AST we consider sacrosanct, so we don't provide an API to it. That said, the DOM AST you can add. So you can do a traversal, you can do all those things out there. Yeah. Yeah, sure. Is there anything?
Are variables renamed or anything in the bytecode, or is it all the way that it was in the actual code?
Let me try to look smart and answer that. So first of all, the variable names is relevant only in local variable table. In the bytecode, the variable names do not even come because we use a load one, event, etc. And yes, we preserve from in the local variable table. And adding to that, we do introduce synthetic variables also into the code, which is not being showed. But if you want, we can show it. So we decided not to show it. So thanks. Yeah. Okay, if you can. That's fine. I can hear. Yeah.
Yeah. Finally clauses are relatively complex. How do you handle those in bytecode generation.
Sorry, I didn't get it.
Finally clauses are relatively complex. How do you handle them in bytecode generation?
I don't know that. Finally clauses. Jafan, you have a...
So you have try, and then finally?
Oh, try and final, you're saying?
The final, yeah.
Oh, that... So if you're talking about... if you're talking about auto-closable classes, auto-closable try variables, is that what you're talking about?
No, I mean just a normal, you have a try block with a finally clause at the end.
Oh, yeah, that...
And how do you generate that?
Oh, that is... that's actually using... how do I say that? There would be a jump into the finally clauses. I can show you the code if you want.
Yeah.
You want to? Yes. Because there would be a exception table if you look at it. And if the exception table would say, if you have an exception that is coming from 0 to some 10 to 12, jump onto this particular line of code.
Right, but I've seen those clauses duplicated in the bytecode, right? And it's sort of difficult to see where they start and end. Well, start is pretty obvious, but the end. So you might have several entries in there. And are you doing the same thing in your compiler?
See, if you look at the exception table, then you would have a exception and a jump target. Is that the duplication is? I didn't understand what were the duplication you're talking about.
So you have a block of code that you write for the finally.
Mm-hmm. Yes.
And because there's different ways you can end it up in the finally, like if you take the exception, you can end up there. If you take you fall through, you end there, right? So you would have different jumps to the same code, but after the finally, you do something different because you may throw an exception or do a normal return. So what I've seen is that that block of code is duplicated for each of the different cases that you see.
Stefan.
Let me guess, because I didn't write that code, but my guess is that the duplication is needed exactly to differentiate the normal case and the caught exception, because both blocks have different assumptions regarding what is definitely assigned or not definitely assigned. And so the bytecode verification for the both cases may need to be different. But that's just a guess.
It used to be that JSR was used to do one block, and then you jump back and return, but that's not the case anymore.
Frankly, I don't know the answer. I'll have to look at the... If you can send me a code which can...
Just write a small piece of code with a finally block, and then send it through your tools, and you'll see what I'm talking about. I think you'll end up with more than one try area with try range, and then the code in the finally block will be duplicated. I mean, this is what I've seen with the Oracle compiler, and I saw an article from IBM that discussed the same thing.
I don't know the details.
Okay. What is supposed to be written in the try block? Well, I just need to write something in there, and then write something else in the finally block. I don't know.
Okay.
Set a value in the try.
So if...
You have to have something in the try block that actually throws an exception. Otherwise,
Okay, I think that's better. Okay, thank you.